Today we are going to present about the topic difference between microprocessors and microcontrollers, its current trends and challenges of embedded systems. So about giving a brief description about microprocessor and microcontroller. A microprocessor is a controlling unit of a microcomputer wrapped inside a small chip. It performs early operation that is arithmetic logical unit operations, which includes addition, subtraction, and not, etc., and communicates with the other devices connected with it. It is a single integrated circuit in which several functions are combined. These are the types of microprocessors shown. Intel Core i9 is the latest model. Now talk about the microcontroller. A microcontroller is a chip optimized to control several electronic devices. It is stored in a single integrated circuit which is dedicated to performing a particular task and execute one specific application. It is specially designed circuits for embedded application and is widely used in automatically controlled electronic devices such as remotes, etc. It contains memory, processor, and programmable input output. It is a figure of a microchip. Now coming about the main topic, the difference between microprocessor and microcontroller. Microprocessor is the heart of the computer system, and microcontroller is the heart of an embedded system. So, what is an embedded system? An embedded system is a computer system. It is a combination of a computer processor, computer memory, and input-output peripheral devices that has a function with large mechanical or electrical system. Microprocessor, it is only a processor. So memory and input output components need to be connected externally. But in the case of a microcontroller, it has a processor along with internal memory and I/O components. Memory and output I/O has to be connected externally in microprocessor, so the circuit becomes very large. As in the case of microcontroller, uh, these will come along with the processor and internally, so the circuit will be small. Cost of the microprocessor system is very high and that of microcontroller is very low. As discussed earlier, due to external components, the total power consumption is high, therefore it is not ideal for the device running on stored power like batteries. In the case of the microcontroller, as the external components are low, total power consumption is less. So it can be used with devices running on stored power like batteries. Most of the microprocessors do not have power saving features, but in the case of microcontrollers, it offers power saving mode. Coming to the use, it is mainly used in personal computers, that is microprocessor, and microcontrollers is mainly used in washing machines, MP3 players, and embedded systems. Microprocessor has a smaller number of registers, so the operations are memory based. But in microcontroller, it has more number of registers, so the program becomes very easier to write. And in microprocessor, it is central processing unit on a single silicon-based integrated chip. But in the case of microcontroller, it is a byproduct of development of microprocessor with a CPU along with other peripherals. Microprocessor has no RAM, ROM, input-output units, timer, and other peripherals on the chip. But in microcontroller, it has a CPU along with RAM, ROM, and other peripherals assembled on a single chip. It uses external bus interface, RAM, ROM, and other peripherals in microprocessor, but in microcontroller, it uses an internal controlling bus. These are some of the features of both microprocessor and microcontroller. Microprocessor-based systems can run at a very high speed because of the technology involved. But in microcontroller-based systems only run up to 200 megahertz or more depending upon the architecture of the microcontroller. The main usage of these systems are coming. A microprocessor is used for general purpose application that allow you to handle lots of data. It is used in calculators, accounting systems, military application, etc. Microcontroller used for application specific systems such as in mobile phones. As a microprocessor is complex and expensive with a large number of instructions to process. In microcontroller, it is very simple and inexpensive with less number of instructions to process.
Now, let's see the recent trends in embedded systems. With the fast developments in semiconductor industry and very large-scale integration technology, one can find tremendous changes in the embedded system design in terms of processor speed, power, communication interfaces, including network capabilities, and software developments like operating systems and programming languages, etc. First, we can look upon the embedded system design in terms of processor speed and power. With the advancement in processor technology, the embedded system are nowadays designed with a 16 to 32-bit processor, which can work in real-time environment. These processors are able to perform high-speed signal processing activities, which resulted in the development of high-definition communication devices like 3G mobiles, etc. Also, the recent development in VLSI technology have paved the way for lower power battery operated devices, which are very handy and have high longevity. Next, this item is the communication interfaces. Most of the present day embedded systems are aimed at internet based applications. So, the communication interfaces like Ethernet, USB, wireless LAN, etc., have common resources in almost all embedded systems. The development in memory technology also helped in porting the TCP Internet Protocol stack and the HTTP server software on the embedded system. Such embedded system can provide a link between any two devices anywhere in the globe. Next name is the operating system. With recent software development, there is a considerable growth in the availability of operating system for embedded systems. Mainly new operating systems are developed which can be used in real-time applications. There are both commercial real-time operating systems like VxWorks, QNX, Windows CE, and open source RTOS like RT Linux, etc. The Android OS in mobiles has revolutionized the embedded industry. Next, the current trends in programming languages. There is also remarkable development in the programming languages. Languages like C++, Java, etc. are now widely used in embedded application programming. For example, by having the Java virtual machine in a mobile phone, one can download Java applets from a server and can be executed on your mobile. In addition to these developments, nowadays we also find new devices like ASICs, that is application specific integrated circuit, and FPGAs, that is the field programmable gate arrays in the embedded system market. These new hardware devices are popular as programmable devices and reconfigurable devices.
Now let's move to the topic challenges of embedded system. First one is amount and type of hardware and software needed. Optimizing various hardware elements for a particular design. And we know that embedded system comprises of hardware and software. As hardware components is increased, cost also gets increased. And if we decrease hardware, the speed gets decreased. So there is a challenge in selecting the size of hardware. Eh, if software is more, cost can be reduced but speed decreases. So it's a main challenge in selection of hardware and software. Based on the application and capabilities we need, we select the type of hardware and software. Next is considering design metrics. Power dissipation. As the power to a system is increased, a main portion of this power is dissipated as heat. So we should find a way to reduce power requirement. Next is physical size and number of gates and engineering. Physical size in the sense, if we implement more hardware, it increases the physical size, weight as well as the area requirement. So we try to make physical size as minimum as possible. Next is prototype development and manufacturing cost. After the development of prototype, we make the manufacturing cost as low as possible for a reasonable price. Next is power dissipation optimizing. Power dissipation destroys the hardware, so we should reduce the heat generation. If the processor clock rate is reduced, the power requirement as well as the heat dissipation is reduced. operating voltage reduction. We should provide minimum operating voltage for the working. It leads to uh, low power dissipation. Next is disabling or controlling certain units when not needed. It also leads to save the power. Next is process deadlines. Challenge in reducing cost by meeting deadline of all processes in the system while keeping the memory, power dissipation, processor clock rate. We should keep a deadline for the cost, so for the manufacturing we should not exceed that cost. Next is flexibility and upgradability. Ability to offer the different version of product for marketing and offering product in advanced versions later on. When we make a particular product, we should be able to release its updated versions of that particular product, and we should be able to correct the bugs and launch new versions. Reliability and safety. Designing reliable product through testing, verification and validation is a challenge. We should assure its safety. It should be certified by agencies that it is safe and reliable. Time to prototype, time to market. Time required to build a working version and time required to develop a system so that it can be released and sold to the customers. We should keep a deadline to manufacture, and for marketing we should be able to manufacture and market it within that time. We should stick on to that time. Testing, verification and validation. Testing to find error and to validate that the implemented software is as per the specification and requirement to get reliable product. First we keep some specification and requirement during the prototype manufacturing. This should be verified and tested. Thank you.